wanted to talk today about the periodic table, and we've been talking about how it's organized. So if we look specifically at group 1, those are the alkali metals, right? And so if you look at the top, you got hydrogen, which is not really an alkali metal. It's just kind of thrown up there because it's got one valence electron. Then you got lithium, sodium, potassium. So you got lithium, which is number what, 3?
Yep.
And what's sodium?
11.
11. And what is the next one?
Potassium.
Potassium, which is
19.
19. Now, this stuff you actually consume, don't you? Well, you definitely consume sodium, right? So where do you get your sodium from? So yeah, so table salt is like NaCl, which we probably eat a lot of. Some people have too much in their diet, and they gotta cut back on the sodium. What about potassium? Do you eat potassium?
Yes.
So where is some potassium found? Bananas. All right, so that sometimes they say helps with cramping and stuff like that. General idea is that yes, these metals are, you know, not so foreign to us. We understand that these are the pure metals that we're going to see today, though. They're not actually the compounds like you would see here. It's not mixed with a chlorine. This is like elemental sodium. So we're going to start with this sodium, lithium, and potassium. Which one should we start with? Let's just start with lithium. Right, so we'll start with lithium. And before I even open it, what I'm going to do is grab some gloves, because I don't want to touch this with my bare hands. Because if I touch it with my bare hands, and then I get some on my hands, and then I wash my hands, then it might not be so good, because then I'm going to have potentially a reaction happening on my hand. All right, so I got my hands protected. You guys are pretty much protected. Far away with some eye protection, and I got my, I guess I could do this too, so I can look super official. I got my lab coat on, and then the last step would be making sure my eyes are protected, because you only get one set. Okay, so now I think I'm ready to start dealing with this. So we're going to do the lithium first, and so I want to do a couple different things with lithium. One is I want to show you what happens when you heat it up. So this, you've probably not done this stuff today, at least on this scale. So we're going to take some lithium first. So this lithium, all this is stored in oil, all right? Why would it be stored in oil? Why? It doesn't react with what? Water. So like if you look here, the oil doesn't mix with the water. This is just water with food coloring and stuff, right? So it's hydrophobic. Oil is hydrophobic. It gets rid of the water. It provides a nice protective coating for the metal. So it doesn't react with, is there water in the air? Humidity. It's being sucked out of the air over there by the dehumidifier. So yeah, we don't want it to react. So now here's a pretty, big chunk here. So I'll kind of show you what it looks like. It's like dripping with oil. That's 2 different big chunks of lithium. So we don't really want all that much. Other thing about lithium is that it's a soft metal. So you can actually pretty much just cut it, like I just cut that apart just with this little spatula. I'm going to actually take this out, put it on a clean section of my brick. It's covered in oil. And so I'll just show you how I can, it's kind of like butter if you were to take it out of the freezer. I guess that's a good analogy. So I'll cut it, and I'm not afraid about touching it right now because I got gloves on. This one's a little harder to cut. Like, have you ever had butter in the freezer before? Take it out, and it's like, you can cut through it, but it's a little tricky. All right, so now I got a big chunk. That's good enough for both experiments that I want to do. And I'm going to put the other one back. I'm not all that worried about contamination. That's pretty much my last piece anyway. And it's nice and protected back in that oil. I don't have to worry about it. So now this piece right here, I'm going to do 2 different things with it. I'm going to cut it in half, and I'm going to use half of it to do one experiment, and then I'll do the other half for another experiment. So cut that piece in half. This one's the hardest to cut for sure. Okay, so I got about half, and notice how it's shiny too. See that? So it's shiny just like you would expect from a metal. and not necessarily all metals are, but you get what I mean. So it's kind of looking like a metal. So we'll put one piece here for storage, and then I'll grab a little bit of paper towels, and I'll wipe off the oil. So there's an oil layer on here, and I'll kind of wipe some of that off so we can maybe see a reaction happen, and I'll put it right there. And I'll try to get rid of some of this other stuff that's right near it, so you can for sure see what's going on here. So this is that piece of lithium. Take that away. First thing I want to do is let's start an initial reaction between methane gas and the air, right? The oxygen that's in the air. So this is my initial reaction that I'm going to do right here. Got to turn it on first, right? Okay, so now I have the flame source. Now this is not the reaction that I care about. I care about what's going to happen when I heat the lithium up. So we're just going to use this to heat the lithium up to a super high temperature. We'll see what happens. It almost kind of starts to melt after a while. It's like, imagine having that frozen butter, it's sitting on the counter for a while, now it's getting even softer. You can kind of touch it a little bit, it starts breaking apart. It almost looks like mercury now, where it's like a nice liquid shiny metal almost. And so we'll heat it up to the point where hopefully we see something interesting happen. We'll see if we can heat it up to a high enough temperature where it just reacts kind of by itself with the air, maybe. Yeah. So heat that up. And remember, the flames that you see right now is not really what we're interested in. We're just using these flames to release the energy needed to start the reaction that we're interested in. So it actually would be easier to do this with a Bunsen burner, because then or like a flame torch or whatever, because then I could adjust the amount of oxygen going to the flame and get it hotter. But this just looks cooler, doesn't it? So we're almost there. And we're about to potentially see something. Just keep heating it. It's almost like bubbling in there a little bit. I can see it from here. I got a really good viewpoint. So I see a couple little spots that are kind of starting to turn black. It almost looks like there's something that's about to happen. And get it in the hotter part of the flame there. Get it nice and hot. Actually use this spatula a little bit, because I don't want that, like, it's almost like a protective coating that's on there. I don't really care about the protective coating. There we go. It's almost there. You see that red?
Mm-hmm.
We're almost there. And then I'm going to quickly turn this off. There. So now it's on its own, right? Look at that. That's its own thing, and it's like a firework almost, right? And then it's like a molten lava almost. It looks like right there. Yeah.
You got it.
Yeah, I got it. So now you see some smoke. Luckily, it's being sucked up by the air system that we have in here. I got the fan on. That's why the screen's vibrating right here, because it's being sucked up. Okay, so that is lithium reacting under extreme temperature, right? Now we're going to do this something similar, but it's not going to involve heat, because that kind of took a while, right? If I did that with everything, it's going to take a while. And I really don't necessarily want to test everything like that, but I did want to show you that you can heat lithium up and have it do something cool. The next thing I want to do is take this other piece of lithium and put it into water. Yeah. Yep. You can videotape it. And so this next piece of lithium, so we're still on the first metal, by the way, right? We're still talking about lithium. And so I'll take this. I'm kind of making sure that the water's off of my gloves and everything. I don't want to touch it and have a reaction happen prematurely. But prior knowledge has told me that when I take lithium and I, react it with near water, like with water, it's going to be pretty violent potentially. Actually, you know what we could do? We could get super far away just in case. I could drop it with this meter stick that's kind of already broken. All right. So, you ready? So we're just going to drop this chunk of lithium into the water and we'll see what happens. Okay. So it starts bubbling. Clearly that's evidence of what? Production of a gas, right? So there's gas being produced. And if I get too close to this right now, I'll actually start suffocating. Like right now. It's kind of hard to breathe. The reason why it's hard to breathe is because all the hydrogen gas that's being produced right there, it's pushing the oxygen away. So I'm trying to breathe the air, but it really doesn't have a lot of oxygen in it. So I'll get close enough and I'll hold my breath and I'll show you how this affects the flame. Sometimes it'll catch on fire all by itself, but watch this. Watch the flame color. See how it turns color? So clearly there's something there that's messing with the flame color. See that? It's like turning the flame red. Alright? Clearly something's going on there. We're producing a gas. If you get too close, you start to suffocate. And other than that, there's not all that much that's happening. Notice how it almost looks like there's something else being produced too, down here. Like some sort of a white substance. Like it's definitely, the water's not as clear as it used to be. Well, the water's not as transparent, I guess you could say, as it used to be. Okay, so right about here. So this is like the as close as I want to get to it right now before you start suffocating too much. And you can kind of tell. It like takes your breath away. All right, you get too close and it literally feels like you're breathing and you're not getting anything from it, and it feels like you're drowning almost. It's kind of a really weird feeling. So now I go to touch it, and I'm just going to just briefly touch it because it's going to be hot. Yes, it's super hot. Like it would be so hot that I really, if I were to pick this up and go dump it in the sink, in the process of me doing that, I'd probably burn and kill some skin cells. Don't want to do that. But clearly there was a lot of what released? Energy, yeah, tons of energy being released by that reaction. Gas is being released, something else is being released. Definitely a violent reaction, not like super violent, but definitely something that we don't want to mess around with too much. It's cooled down to the point where I can touch it now. So I'll empty the products here, and it's cool enough where I'm not going to shatter my beaker with thermal shock. Okay, so now I'll get some fresh water. Okay, because I think I definitely was producing something that was contaminating the water. So we'll just make sure we have some nice fresh water. Now that's tap water. I could be using pure water. There's definitely already some things in that water, right? But I don't really care all that much. It's mainly the water that I'm interested in. So wipe that water off my gloves and let's go on to the next one, which is what? Sodium. We didn't even do sodium yet, right? That was just all lithium so far, right? So now we got sodium. So now this is stored in a very similar way. So it's got all sorts of desiccants and like oil and stuff like that. So we're going to take a piece of this and we are going to see how this one reacts. So this one cuts like butter that you took, you just took it out of the refrigerator. So it's it's a little bit easier than the last one, and I was able to just cut off a nice little chunk there. I'm not being super scientific about this, like I'm not weighing it or anything, but it does look like it's a very similar sized chunk to what I first used. Okay, so I'm just drying it off a little bit, like getting that oil off of it a little bit. Okay, so now do the same thing with this guy, and we got some fresh water there. And I'll put it on my super safe broken stick. And we'll drop it in. You ready? So this one is sodium. Sodium metal. Here we go. So definitely looks more violent right now. Caught on fire all by itself. And it will just kind of float around there. And then eventually kind of explode out, pop, and get more violent. And now the safe zone is like right here. So like I get in a little bit more, I start to suffocate. So I don't want to get too close to that. You got a whole bunch of hydrogen gas right there. That was what the explosion and the fire was, right? It's pretty much getting rid of, remember you got H2O, right? So if you got H2O, you're able to get that hydrogen. Right? And that hydrogen gas is the explosive, flammable gas that we're interested in. So, would you definitely say that's more violent, right? Okay, so, next one. What's the last one that we're going to do today?
Potassium.
All right,
Are we
let's
gonna
do it.
more of these?
What's that?
Are we gonna do like more of these?
We're going to do more of them? Like what?
Like not today, but like.
We
you said
might.
the last one
Well,
today.
we might be able to experiment with this a little bit more later on in the year. But as far as what we're learning right now with the periodic table and stuff like that, and why it's set up the way that it is, we're pretty much done after this. I want to show you guys why the periodic table is set up the way that it is, and I wanted to do it in an interesting way. So, this is the potassium. All right, so let me show you what we're going to use. So, it's kind of stuck in there a little bit, but let me get it out. Give me a sec. Okay. Check this out. What if I... Oh, look at that. What if we use that?
Yeah, I just go back a little bit.
No, I'm
Are you
just kidding.
serious?
No, we're not going to use this much potassium. All right, so
I've got no
you can
flag
see
for
how
that.
it's like dripping with oil, and I'm like halfway cut through it. Okay, so we're gonna put like at least half of this back. Look at how cool it looks like on the inside. It's almost like purpley. Look at how awesome. It's beautiful. And it's just weird. Look at that. It looks like bubble gum almost. Like it's just like it honestly feels like bubble gum almost. Like I can smush it in my hands. And then I might I can literally just rip it off like a piece of bubble gum. Look at that. Like this is like butter that has been sitting on the counter for a while. Look at that. That's really a soft metal. So this is definitely the softest of them, for sure. Okay, so now I have my piece of potassium. Okay, and it's all very, very oily, which is good. I'd rather have more oil than less. So I'm gonna wipe that off with a paper towel real quick. And then let's get to work. So, I guess science is just an excuse to have fun, right? So, next and last part. We can see that this metal is malleable too. So I'll bend that back real quick. It's pretty good now. All right, so let's drop that one in. I'll grab my stick here and drop it in from a distance. Well, based off of what we've seen so far, I definitely feel like I should be far away, right? Now, did I change that water? No. So I probably should. So I can kind of tell because it's almost like a colloid now. Remember that? So it's almost like scattering the light to the point where I know that there's got to be something in there. So let's get some nice, fresh, transparent water. And then let me put this on here. Chunk of potassium now. Okay, I got a little bit of fuzz on there too. Okay, here we go. You ready? So, potassium, last one. Instantly.
Oh, that was so cool. Oh my gosh.
Isn't that awesome? Now, at this point, I wanted to show you something. I actually can breathe right now, and I'm not actually suffocating. It's kind of weird. So it reacted so fast that it I want to say that it didn't really allow the hydrogen to really get anywhere, right? Would you agree that probably most of the hydrogen reacted right there? So I would say that that's almost safer in the sense that I don't really have to worry as much about suffocating, at least based on my experience right now being close to it. But would you say that that was the most violent?
Yeah. Can we
All right.
do that again?
Can we do it again?
That was pretty
Didn't catch
cool.
it all. That's true. She did it.
I should have caught it all though. So we did it. So that is about the periodic table, the groups of the periodic table, why we organize it the way that we do. We have metals that, do they all behave the same way? Pretty much, right? Do they all okay? Do they all react violently with water? Do they all produce hydrogen gas? Were they all soft? Pretty much. I mean, I definitely experienced that potassium was the softest, I would say, but they're all pretty soft. You can cut through them with a dull, knife. So, anyway, good job.